Hello, everyone. Thank you so much for joining. We will wait another 10 minutes so everyone can join. I see Stefano is also here. Hi, Stefano. Good to see
Hi
you here.
guys.
Hi. So we just started the session so everyone can join and make sure that everything works. We are live on YouTube now as well. So if you can't access at some point to the event because there's 1,500 people joined the event. So if you can't access the event, go and watch on YouTube. Okay, we're gonna be cam off again, so we start in 9 minutes. So guys, thank you so much again for joining. We're gonna wait another 5 minutes so everyone can join. I see Stefano is here, Ahmad is here, Mahdi will join very soon as well. Until everyone joins, just write in the chat section that where are you guys joining from? You can write the name of your city and country. Thank you so much for joining. Hi everyone. Hi Stefano. Hi Mahdi. And hi Ahmed. Are you guys here?
Hey, hello, Hamid. Once
Good
again,
to
we
see you
meet.
guys again. Yeah, thank
You
you.
too.
Hi
So
My
guys.
yeah,
pleasure.
hi
Hello
Stefano.
everyone. How are you, Mahdi, Hamid, and Stefano?
All good, all good.
Ahmed.
Cool. I'm seeing you, Stefano. You're adjusting
So,
uh your video. Yes. Okay, we can see you clearly now. Yes, great. Well, thank you so much everyone for joining. This is now after a couple of months, we're back and we're with another free session that we're gonna mainly focus on the emerging of new technologies in architecture. And specifically in this case, a great project that these folks did together with the tools called Ardaena, and Mahdi and Ahmed is the brain behind these tools, and also Stefano will join for some lectures. So thank you so much for joining, first of all. And if you're not able to join the Zoom meeting, you can watch the video on YouTube. We have the capacity of 500 people. Almost 1,500 people have registered for this course. So if you're not able to join and watch, make sure that you follow on YouTube. And it's the same video broadcasted to YouTube. The high quality version of this video will be added to our website, so you can watch from there. I see the numbers are increasing and people are joining. So before going into the session, I'll just talk to Elbet, to Mahdi, Ahmed, and Stefano about what we're expecting in the upcoming 5 hours. Then I will do a short update on PA Academy and the events that we have. Then after that, we'll give the stage back to our presenters so they can continue on. So Mahdi and Stefano and Ahmed, so can you guys just give briefly an update for us? What are we going to see in the next 5 hours?
Yeah, shall I start?
Yes.
I
Just a
just,
brief update, then I will do an intro, then we
oh,
can
okay,
go with the
great.
presentation. Yeah.
We are so excited about this webinar workshop, whatever we say about this, no matter what the title for us is to, a stage to share the experience, and we're going to focus on how to use computational design in advanced mode in the building industry. And this is, something that Stefano will follow up with the first, section to, you know, warm it up for all of us a little bit and share his amazing experience. This guy, we call him Captain because he knows what to do on any stage of the projects. And I don't want to talk about it. He's gonna, blow everyone's mind, I believe. And then Ahmed will start to develop an algorithm related to the project. And then I'm gonna join the whole stream of sharing the experiences within Grasshopper and how we apply different, tools and plugins in the whole, section for this project. That's the whole thing. And of course, participant will join to follow up the things on a hands-on project. That's the biggest part of this webinar.
Great. Thank you so much for the brief intro. So I'll just go with an update on our academy and I'll share my screen. Okay. So most of you guys have seen this page, which is our workshops page. And in here we have the upcoming events, which has been written in here in chronological uh, order. So today we have integrated facades. Tomorrow, next week we have AI creative challenge, parametric architecture, and also curvilinear concepts. And the week after that, biomorphic topologies, and which goes on. I'll just do a short intro to each one of the workshops. And so next weekend, we have a parametric architecture workshop with Blender. We will have Dimitar Pershnikov to cover Blender as a parametric design tool, which is among most favored softwares these days used by architects. So make sure that you check this you check this workshop. We did a workshop before, parametric design with Blender, with Dimitar. Now we're doing the second workshop, which is parametric architecture with Blender. We'll cover extensively the capabilities of Blender as a design tool for architects. And also we have a digital member workshop where we will focus on the creation of a workflow from AI to Maya and then Grasshopper. And Prabhat from Zaha Hadid Architects will teach this workshop. He's an Indian designer, but he works at Zaha Hadid Architects. So the workflow will be AI and AI image generation, then into Maya, then into Rhino. So make sure to check that out. And then we will have biomorphic topologies. This is the second workshop that we're having with Andreas. He will cover extensively the Cinema 4D workshop. And this is again next weekend, the weekend after, towards the end of the May. Make sure to check it out. Andreas is also in Pratt Institute and he's a New York-based designer. We will have optimizing design decisions with Zvonko Vugershik, which will be focusing on Lunchbox machine learning system. And if you have checked some of the projects that Zvonko was involved with, this Sydney's 3XN Sydney fish market. So yeah, if you're interested, yeah, you can check this out as well. Another AI workshop is coming up with Carlos Banian with ComfyUI ControlNet tools that we will cover extensively. We did ControlNet before, but this time we will mostly focus on ComfyUI in architecture. You know Carlos Banian's works. He creates exciting visuals in AI using Midjourney, then also ControlNet. We have another workshop which is called GenLogix, Generative Logic and Visualization. We have two instructors here, Soriol and Namar. This is the first workshop we're doing with them, and the extension of this workshop will be a 3D printing workshop, which is another workshop that we will announce after this workshop. So what we will design in here, we will print them in the second workshop. These guys are from EAC and they're based in Barcelona. So yeah, just another great workshop. And the last workshop that we have, which is fractal matrix architecture with Jack Rendler. So yeah, just check these out. So I don't want to go much more into the details. So he's going to use Rhino, Grasshopper, and mainly Pufferfish and Mandbulb. And well, yeah, just check these out and make sure that you join our digital membership program. Some of these workshops were only for members. So if you can just join for €4 a month, to gain access to all these workshops. So if you become a member, you will have access to all these previous member-only workshops that we had. We also launched our full access membership, which just gives you access to all our upcoming workshops. So just with one full access, which is a yearly membership, you can gain access to all our upcoming workshops. So yeah, make sure that you check that as well. And to join our Discord channel, just come to website, log in, and visit this member Discord and connect your Discord to join our server. So this is our server. Sorry. Okay, I think you don't see my screen. Just 1 second. So this is our server where we'll be speaking together like today from here. So this is the chat section of the event. Hi, everyone. Please start writing from here. So if you want to communicate and see all those communications saved, just right from here. Well, that's it from my side. I couldn't find the okay. That's it from my side. So if you guys are ready, let me know so we can start. Yeah, Mahdi and Ahmed and Estefano, you have the stage. Let's go.
All right. Thank you, Amit. Thank you for, these kind of elaborated things that you've added was really amazing. All right. I believe we'll start with Stefano's part. Yeah. Yeah.
Okay.
We can go
Okay,
ahead.
let's go.
Yeah. I just start my presentation, and how is that here? I have to share the screen, right? Okay. So now you see this wonderful background, right?
Yes, we can see.
So you see my presentation.
Perfect. Yes. The cover photo. Yeah. Awesome.
So, Amit, thanks for the invitation. And Mahdi and Ahmed, thanks for your support. And let's kick this off. So I give you a couple of quick things about myself, because I'm quite a newbie in the parametric architecture world, let's say, in the sense of being a promoter of this. I worked with parametric architecture already since I started working in construction. I'm an architect, graduated at the University of Innsbruck. Was there with Marian Coletti, with Patrick Schumacher. We got introduced into Rhino, into Grasshopper, into parametric design, and sort of it started clicking with me, and I was very enthusiastic. Unfortunately, I was already doing my thesis, so I didn't have enough time to deep dive into that. But my first project that I started quite a few months, so quite early after graduation, was Ferrari World that you see here on the top left. That was a massive project that I came in as a project manager, as an architect, and first problem we were facing was already a parametric problem. We had to order these coils of red aluminium that you see covering the whole structure, and basically nobody knew how to deal with this immense amount of data. There were I think around 12,000 panels of aluminium sheets that had to be produced for this building, and nobody knew how to deal with it. So in a combination with Rhino and at the time not Grasshopper because it was too quick, but Excel and pivot tables in Excel, we managed to achieve the procurement phase to order all this raw material and then also produce it. The output was great. It was 1.5 years of my life that I remember vividly all the time. Straight after that, I had the pleasure to work with one of the best facade companies in the world, with Sealy out of Germany. Worked in their Dubai office.
Estefano, can you hear me?
Yeah.
Sorry to interrupt, but I think your mic is a little bit far from your mouth. Can you get a little bit closer to the microphone? Thank you so much.
Yes, I will. 1 second. I just go to the, 1 second, sound settings, yeah, for you.
No, I mean, just get a little bit closer to
Yeah,
the
it's
microphone.
difficult here. It's quite far. My TV.
Okay.
But I get the input here. This one, yeah. Okay. So I try this one to move this one here. But it's better now.
Yeah, better now.
Yeah.
Let's continue.
Okay, let's continue. So I had the pleasure to work with one of the best facade companies in the world, and in my opinion, Siele out of Germany. I was working at their offices in Dubai, and we had this project in Sharjah where the architect developed a shape in Maya and basically dumped it on our table and said, so guys, I want to build this. And luckily, my knowledge of Rhino and parametric design at that time, I don't know if any one of you guys remember Evolute, these guys from Vienna that developed these nice tools. And so I and my team and another Iranian colleague of mine at the time, we developed this shell with these petals, and I have to say the output was fantastic. Yeah, the output was all digital, and I'm talking about now. We are 2024, so it's 14 years ago, yeah, or 13 years ago. At the time, everyone was skeptic about this workflow, and we managed, and we were super happy that it worked out like this. Then another project that I'm really proud of, Capsark in Saudi Arabia, in Riyadh, that I also did with Siele. There we usually used Grasshopper to check work of our design subcontractors. It was also very interesting. And at the time, we suggested to all our design subcontractors to use Rhino. I mean, that was the first thing, but then also to use parametric design to go out, if they don't have a parametric designer, to go to a university and get someone, or to try to do their design work with parametric tools. They didn't want to. Yeah, so what we had to do is develop tools to check their work. So all their 2D, 3D drawings had to be checked automatically, because it was thousands and thousands of drawings and thousands of we had, I think, 11 layers of facade build-up to cover. Everything was intrinsic with each other, and of course, it was a great tool to have, a parametric tool to check all these correlations between each layer. And I always felt a little bit of a pity with the companies, with the design offices that didn't want to comply with our suggestion. But yeah, everyone can do what they want. So next project I worked, I show here on the top right is a string tower in Munich, in Berlin. Sorry. We were developing the whole GFRC shell I was working with an Italian engineering company. And also here, as you can see, this undercuts and overlays of material are quite tough to understand how this works. and parametric design solved all our problems. And even though the workflow is not what a facade contractor, and I come to that a little bit later, expects in terms of delivery, at the end he got everything delivered correctly, named correctly, and was a great success. Maybe someone knows the project of Snøhetta in Saudi Arabia, the King Abdullah World Center for Culture, for Cultural World Center. It's a building that is cladded with a normal facade and a rain screen, but outside there is a 125mm steel tube that is spinning like spinning around the whole building to give him the great look as it has now. And here we were involved already from the early beginning to value engineer the whole structure. Then on the second stage as well to solve all the intersections between the cladding and the inner cladding and the rain screen cladding or windows. I have two more projects that I'm very proud of to have worked on at the campus. Steve Jobs Theater in Cupertino. Unfortunately, there was no need of parametric design there, only hard workmanship, but it was a lot of fun. And the Apple Store in Chicago, there as well. Great glass engineering, great work. It was difficult conditions with unions, etc. Chicago. If somebody from America, from the US, it can tell. Then the last couple of projects that I'm proud of have done was the Parliament skylight in Vienna. It was great working for a facade contractor from Germany, Roschmann. They had to value engineer this skylight again due to the fact that the engineering was not as up to their high standards. And but it was a lot of fun to redo basically the design from scratch. Then this also projects that I was always very happy to work on are these ETFE projects with transparent membranes. That is a material that I came to love with the time. Richard Meyer projects, very clean, sleek architecture. Maybe not the craziest architecture because he's really he likes these right angles, but he has this filigrane kind of design that he likes to do. And just to cut it short, a last project that we are also doing together with Marty and his team. This is a small project in the north of Germany. And here I have to say, we received the 3D model from the architect. We re-engineered it. Of course, we had to do it with Rhino and Python. And the whole output of the model went to different engineers to get the steel, the aluminium, and the glass as fabrication output straight out of the model. I think this is also a big achievement for Madi and his team. It was a lot of fun. It's almost finished. We are visiting the mock-up next week, hopefully, of the steel structure, and we'll see it standing by the end of the year. Now, quickly, something to my firm where I work now. It's a very small boutique studio in Zurich, Switzerland. We're 5 people, not a big team. I put here our affiliation with Building Smart that we find quite important, because as facade engineers, you don't find many that are social or affiliated with Building Smart, and we really think there is a high potential in BIM, in parametric design, and all these kind of things. A couple of projects we are currently working on, where we work together with Ardena and also with other projects, other architects here in Switzerland. Projects are usually in Switzerland or in Germany, or at least in the close area of Switzerland, North Italy, South Germany. That's it. And you see on the top right, there is a sort of a workflow that we started developing for our needs. How do we approach whole design? The faces that you see, it's the numbers that you see in the black dots are the Swiss architecture faces, like then in the RIBA stages in the UK, or the design stages in the US. Here in Switzerland, we have a sort of a similar system that goes from 11 to 53, basically. We are mostly involved from 31, where that is the SDE design, 32 DD, 41 is then the construction documentation, and 51, 52 is the construction. These are the tools that we are using, but I have to say it's I'm back now from 2 weeks vacation. For sure, next week we have a meeting and our workflow will change again, because we are adapting very quickly to the needs of our new projects, and also what the market is offering in terms of tools. We are not holding strong to. We were working with SolidWorks for 8 years now, and thinking now to switch to Tekla. There is nothing that will break us from not doing it. Our clients are mostly high-end facade construction companies or general contractors, of course, as well architects and developers that I didn't put here in terms of because of privacy. Let's deep dive into the projects quickly. I said to Madi I will explain a little bit for all of you how the project was developed by the architect. I got a briefing by the architect. They unfortunately couldn't be here today, but just for you to understand what later Madi, when he's talking about Scott, what he's talking about in terms of design of the building. So basically, project was developed by Integr8.AEC in Bern. Scott, Mr. Beat gave them the direct contract to develop this building, and they looked at the bicycle frame and at the logo. On top of the on top you see their top right you see their logo, and they tried to find somehow translation between the logo, between the bike or other sports tools to the building. And for sure, for them it was very important to design a technological building, because of course they're a technological company in terms of sports technologies, with bicycles, with skis, with other sports equipment that is quite technologic, and this was this sort of transliteration to this building. On the lower image, you can see this building has this wave at the entrance, and this came from the wave of the water or the wave of the snow. In terms here in Switzerland, of course, it was more the wave of the snow, as Scott also doesn't really have water sports equipment, more mountain equipment like skis and snowboards. Project started 2015, so already a while ago, completed 4 years later, 60 millions of cost. The facade was 10 millions. So quite an expensive facade for a building like this, over 100,000 cubic meters of volume and 4,000 square meters of footprint. And the most interesting part I find is that Integr8 at the time wanted to design the first BIM one of the first BIM projects in Switzerland. At the time, 2015, BIM was a word floating around, especially here in Switzerland. I have to say we are for sure not that advanced here in Switzerland as I was used in the US or I know in the UK. Therefore, for them, it was very important to be a sort of a pioneer in this field. ID Partners, on the other hand, started this project by very early. We got involved already in the first phases of the design. The architect had a rough idea how the design should look like, with this wave, with the triangles I explained to you before, because of the transliteration of the triangles. But there was no idea behind how to develop this facade, how it should really work as a facade. So in the first weeks of discussion, we had we gave them some hand sketches, and that's what we love to do. The first thing, we are not going to draft anything on CAD or on details done with CAD, but with hand sketches. Hand sketches are the most or the best tool to transmit a feeling how a facade should look like. It's very unprecise. That's very good to just show roughly how to develop this facade. So this double skin facade was immediately the solution that we approached. The architect didn't want to see any motorized bars to open these blinds, so or the outer shell basically. So we had to come up with a movement of the shaders that is inside the pivot of the triangles. And at the time, of course, the shape of the triangles was given, let's say. Yeah, there were not many variants possible to analyze. You will see later that what Mahdi and his team made, that's absolutely great in terms of optioneering of and how you can analyze this kind of shapes much further. We would have loved at the time to have it like this. So basically this double skin facade means there is inside a facade, glass facade, a very, let's say, normal window facade. And then on the outside, we fix these metal panels that can open and close like a shading. At the beginning, the architect was also contemplating to have wood at the inside of the building. You will see later a couple of pictures as well, and aluminium on the outside to have this division. For the facade system at the end, then we developed the design as an aluminium element facade, and the whole project then was further developed by the facade contractor anyway. Further, you can see in the section there is a skylight, a straight skylight, and this skylight is the glass was an electrochromic glass that can be switched to the dark mode. I don't know if you notice this kind of glass, but also this was the first time that this glass was used in Switzerland as facade or envelope glass, and was quite an interesting development also for this actually French-American glass company. The same glass was then also used in the auditorium, in the mezzanine, for the facade glass, because there they have some presentation rooms, and when they present a brand new article, a brand new bike or a brand new product, they can shade it off for privacy of the product and of their clients. Sorry, no, I clicked one too much. So this a little bit the construction that I showed you before. You see on the top right, the completely closed facade panels. Every panel is openable, and they are controlled individually or also via a program that can open the whole facade simultaneously. That is, of course, not a problem with building automation. A few more details of the open facade. You see on image 4, you see the window facade on the inside, and then the catwalk, and then the outer facade, the sun shading. And on image 6, the technology behind, how the pistons open on the shading on the pivot of the instead of having an arm cantilevering or anything else that doesn't reflect the sleek and nice architecture that the architect had in mind. Here, this few pictures from the inside. You see here this concrete wall as well was thought of a sort of a wave. They were first thinking even to put a skate park inside. That was then discarded. And inside everything is in wood. You see the skylight as well, and an old construction picture I found about how much light comes in actually through the metal facade, to the closed metal facade. It's very shaded, but at the end, the view to the outside is fantastic. A couple of things. I was here at ID Partners are important for us when we work with models and with data for computational design. I think it's there is a couple of very important things that we need, and I wanted to give it to the audience to reflect on this, and maybe some architects also can take advantage of this. So basically, we are working with reference models that we get, IFC models or Rhino models, and these are very important for us that we get them correctly, and or that they are built in a correct way with all the information that we need. The second thing is what we expect usually is that the facade system has to be defined and resolved. So if not, of course, we are happy to help, but usually we are getting into the stage of construction design as well. And if the facade is not defined and resolved, then we are running into many problems because of resolving these first, and then we lose a lot of time in these kind of things. Also, a well-structured and logic relationship between elements, substructure, panels, windows, has to be established. So I usually also suggest to have a facade engineer or a facade consultant to assist an architect in the design of a facade. It must not be a very complex facade, but this logic between a substructure and an outer shell, it's very important to have. Further, we have to have a clear architectural design that comes then becomes a good script and a good production design. and as well the schematic model that must be precise. We, in these terms, what skills we also need is a production knowledge of facade items. Without that, you can be the best computational designer, but without a production knowledge, you're just doing things that might be completely wrong on the as an output. Of course, technology savvy, and then as a computational designer, you should know what is the output that is needed. Do we need step files? Do we need PDF files? Do we need DXF and DVG files? What is our client asking us as an output? Further, you have to recognize, or to be able to recognize, patterns of a facade, and then also to work in a rational and structured way. So you recognize the pattern. With this pattern, you can then build a structured and a structured model, computational model. To close now this whole discussion is what is the goal for us to build parametric models. It's not to have just to have a parametric model or to work in a parametric way because we believe in it. It's also to add much more information to what we do. So basically, with a parametric model, we can resize in real time, resize massing, grid lines, story heights, and our output that we want to get. And Madi will show it to you later in his presentation. He can show you real-time cost, output, or carbon CO2 feedback, or building physics information that we need for to further design. This is for us, I think, one of the most important topics. We are building a small database with facade-related database where we can we have the input of a lot of data like cost, the EPDs, the fabrication times, the production times, the installation times, and out of our parametric model and changes that we do in grid lines, in panel width, we can find the optimal way of cost or installation times, etc., etc. I think this is our aim for to work in the future, and for what we look for a parametric, what we need from a parametric model. And I think Madi and Ahmed now are the best to share with you their approach and how they made it happen for Scott, and how they also did it with other projects.
Right, that was really interesting. Hamid, will
Thank you
you
so
get
much,
the question,
Stefano.
or I should take on it?
Yeah.
All right, yeah, great. You're up.
I'll go through
ahead.
them. So guys, write your questions in the Q&A box so we can see them and ask them from Stefano. So Stefano, what do you mean by model must be precise?
So basically, when it comes to production design, we are receiving the most different ways of either an IFC file or an ArchiCAD file or Rhino models, and here we see the difference how an architect approaches its design. And I'm not saying this wrong, that the architect has other aims to design, but what we see sometimes, not many luckily, is like grid lines. You know, we have a grid line of 2.54 meters of the whole facade. It's a very special size, and the architect or the architect's model has the grid line is 253, 253.5, 254, and all different sizes. It's not made in a parametric way. Eventually, it's made somehow, yeah. And therefore, we would love to get a model that was made with the parametric tools to get these kind of things. Then we work on a different scale of precision. When our output is on, let's say, 0.01 millimeter and from the architect it comes, if it's an IFC done with Revit, we know already that we have to redo it, yeah. So and redraw. When it comes with Rhino, there is certain the precision is very good, but also what it happened sometimes that the architect didn't know the technical peculiarities of materials. So he designed steel beams or glass in a way that is not feasible to produce. And so it's we have to redo the whole model again. So to have this wish of the parametric design to start from the architecture and go through the production, oh yeah, you can use my model to produce it. That would be the fantastic workflow to save a lot of time. Usually this is not what's happening. Usually we have to start from scratch and rebuild the whole model again. That's
great. So Hussein also says, how many architects of the building came up with the format design? I mean, what was the design process? If you want to briefly talk about it.
Basically, it was quite a quick design process. From the architect's side, I spoke to them and was also interested on the approach, but the form or the shape was given by the area it could build. There was the original Scout headquarters was an old hut next door, and they were thinking to build a second building there. So this was kept rather small. That now, after the pandemic, is fantastic. And the shape, the height was a quick sketch from them and was given. And this design process within the facade then was workshop relationship. I think it was 5 or 6 months work of different couple of workshops and a couple of design meetings to get this out. It was quite streamlined on the end. They gave us a lot of freedom on the inner shell. They were like, okay, guys, how do we get this building weather tight? Of course, then if it's a double skin facade, you needed to design the protrusions through the facade, how to hold the whole metal facade, but it was quite a straightforward process with a lot of freedom on our side, I have to say.
Cool. So Jibril also says, what material is the facade made of, and what abort it effect on the environment?
So the material is aluminium. It's a perforated aluminium facade. And I didn't wait a second. Maybe I check this. What was the second question?
And what abort it effect on the environment? I don't know what does the second part. Well, probably what about its effect on the environment? Probably, if Jibril,
Yeah, I
if you
think
want
it's
to
from
elaborate.
the sustainable view.
Well, it was 2015 when sustainability was, of course, somewhere.
Just on paper. On the cloud.
but life cycle analysis or no. But on the other hand, I have to say, if you do it properly, an aluminium facade can be made out of recycled aluminium nowadays with technologies. If I would redesign it, I would just change the specifications and not the material. That's the problem is of course if we only design aluminium facades the whole time, of course there is not enough recycled aluminium. But why not clear it in the specifications to say, okay, we want a perforated aluminium facade out of 3 millimeter recycled content, 80% plus 80%.
So we've got so many questions. Short answers will be highly appreciated. So I'm going through all of them. So what were the main problems with the Revit model? Lucas says.
On this project, luckily we worked with Archicad, and the architect worked with Archicad. But I'm just generally referring to Revit models that when we get an IFC out of Revit, of course Archicad we could get the native data, but from Revit we get an IFC. We don't have the precision that we need to translate it, to translate then the dimensions that are necessary for us. We rather redesign it in Archicad quickly to be sure that we are having the correct dimensions. It's a, you know, when you go to the construction design to production design, you have to be really sure that everything fits to the millimeter. We are not working in with steel or with concrete where there can be tolerances. We have a millimeter plus minus. That's what it is. Yeah. Else water will infiltrate and we have a damage.
And Caesar says, hello, Stefano. Does the thermal regulation savings surpass the maintenance costs of all the components?
Does the thermal regulation savings? We didn't do any analysis in these terms, I have to say. As I said before, it was 2015. There was no question in these terms. But this would be a quite interesting question for the next project. I have to say for a new project, if it's a refurbishment, for example, you have to see is the HVAC company or engineer also involved. If they don't want to change anything there, it doesn't really matter. Else, yes, it would be very interesting to see if the cost of the maintenance is surpassing.
Yeah. And Kaluyan says, why did you work in Rhino and Grasshopper? Would it be possible? Probably this question is much better if Mahdi replies. Would it be possible to create this facade directly in Revit and adaptive components?
Mahdi, what's your opinion?
Oh, yeah, in these kind of stuff, I believe there's no such thing as an answer that, all right, this software would covers all of the problems in the model that you have, 100%. And I believe, mix and match these softwares within this kind of stuff is much more reliable. When it comes to real stuff, when you want to model something, a conceptual one, yeah, you can go with one specific part, and adaptive models in Revit works really fine, I know. But when it comes to grab the model with the data and add and remove some beam data into it, Grasshopper can actually help you a lot. And in these cases, one of the pretty challenging part is to taking out the data beside each specific element of the whole system. And in those cases, SolidWorks and Inventor comes up. You need to revolve all around these tools. There's no such thing that, all right, we're gonna have the whole thing inside one software. So my answer to these type of questions is always that you need to find what exactly you want to get, and you go to the perfect software at the moment.
Great. And Iman also says, maybe Mahdi, you can also cover this question. What are the softwares and plugins you used for the multi-objective optimization? Which parameters? And did you integrate lifecycle analysis in the process? If yes, is it on Grasshopper? By which methods, please? Just briefly, because we have to, get over
sure.
the
There is no optimization in this project. Mostly multi-object optimization is really tough to follow. Although I can actually help you with that kind of stuff later because we have a research on that. And what was the next one?
Did you integrate LCA lifecycle
LCA,
analysis?
lifecycle assessment. No, not applied on this one.
Okay, and that's done. Hagar says, how is the workflow integrated with Python? What is the purpose and the goal of coding in this process of design and work?
Yeah, that actually would be followed by some of our videos we're gonna share with you guys.
Okay.
Developing using Python, add a specific part of the whole script. You're gonna find out easily after this part.
Okay, great. Okay, the first part. Hussein says, how did you convince the client of this project to spend that much of money for making this facade feasible? I mean, is it good design? But I mean, it's a good design, but making it into real life costs so much.
No, I understand. Sometimes I understand this question, especially here in Switzerland, where usually the design is very rectangular, practical, good, sleek, and not much of an big effort in the skin of the building. But I as an architect, I say it's like with clothes, you know. I like to wear nice clothes. They of course are higher quality and they cost more. End of the story. If I like that, I have the money. Why not? A bike of Scott, race bike, costs around $10,000. Can buy 2 wheels and a handlebar and ride a normal bike for $50. You know, it's the matter of it's not that. And we really like to make nice facades, and this one was by far not the most expensive that we designed. I mean, I think Madi, what we are doing with Lorelei is on a square meter. It's much more.
Cool. Last 3 questions. Hagar says, how do you see this workflow in the context of retrofitting existing buildings, maybe to improve environmental performance?
Yeah, excellent. Tomorrow I have a pitch. No, after tomorrow I have a pitch for a project like this. Fingers crossed. And then we will apply this straight away. This I think it's absolutely applicable.
Okay, next one. Hi, Stefano. May I ask, does the rationalization process of the geometries taken over by the engineer? And so does the architect need to pass over the grasshopper files to the further refined? Further refined.
Yeah, I think basically yes. If the workflow would be architect decides something in Grasshopper, he has either to give the definition to the engineer or sort. The engineer has to read the baked output. It depends on the relationship between the two. Yeah, but yes, that would be cool if the definitions can be exchanged. And I'm for open BIM, for open Grasshopper. Why not open data?
Yes, and also Julia says, what is the difference about sustainability from 2015 until now, 9 years? So I mean, in practice, what is the approach of clients when they request a new project?
I have to say, from 2015 until now, the world. By 2015 in Switzerland, there was nothing. And now, 2023, 24, we're slowly, I mean, I'm talking about Switzerland because this project is in Switzerland. I know in the rest of the world it's different. I worked there. I was there. When I came to Switzerland, it was mind-boggling for me as well that now in 2023, we're starting to talk about sustainability slowly. And I'm pushing it, but you know, we're a very small studio and cannot change the world. So from our part, we are environmentally conscious and design for that. What the whole world does now, it's very, very different from 2015 already. I have to tell you, 2015 there was basically nothing in these regards.
Well, that's great. Last question, funny one. Victor says, are you related to Aldo Rossi?
No, it's no.
Okay, just similar names.
Yeah.
There are plenty of Rossies out there.
Okay.
There's many. I think it's the second last name in Italy. Second frequent. Okay,
Well,
thanks guys.
Thank you so much. Stefano, this was really nice lecture. Yeah, looking forward for your great projects. And I was amazed also with the showcase of different projects that you worked on and the different analysis and the teams that you built for doing this project specifically. Yeah, congratulations on everything. And thank you so much for joining and for this lecture.
Yeah, thanks for having me.
Have a nice day.
Yeah, bye-bye.
Bye. Okay,
Thank you,
Mehdi
Captain.
and Ahmed, let's go.
Yeah. Right. Should we take a break or we just
Yeah, let's do
continue?
5 minutes break and then
All right, great.
continue. Yeah,
Right, see you.
perfect. See you.
Okay, we're back. Why do you have me?
Yes.
Okay. I think Hamid microphone is off. Now he's praised. Why, thank you guys for approving that. Let's just wait if Hamid can come back so we can start. Meanwhile, you can download the links and the Google Drive and related files because I want to talk in just 5 minutes and Ahmed will take on the mic from the corner of the office. They can follow the workflow as a hands-on project inside Grasshopper. And Hamid is still phrased, right? Isn't that poker face? Maybe the whole PA team is off. Okay, maybe it's better to start without them, I think, since everyone is here and can share again the file. Yeah, let me Ahmed, do you have the link? All right, thank you. Yeah, I'm gonna share my screen so we can start this. Where is it? All right,
Hey,
this. Hey,
we had some tough time regarding the internet in the office. So can you hear me now?
yeah, you have your voice.
Right, right. Let's see your screen. Do you need anything from my side?
Not yet. I just have your voice really dizzy. Should we continue without you?
Yes, yes, let's go. Let's
All
continue.
right, go ahead.
Great.
Yeah, guys, I'm gonna talk about other than just in a 5 minute presentation. Just turn it back to the beginning. So you can find out what we do as a hybrid team with research and pro experiences all together. This is what I believe AEC needs. AEC needs hybrid character who knows about how to do a research inside computational design and how to grab their knowledge into the building industry because the demand is different, but the tools can actually be shared. And that's the real thing. We're going to talk about this today. Since we were started to work with computational design tools, we defined our with two wings, one pro for design, engineering, and fabrication. The other is research and development for learning, teaching, and research. Each side has some preferences to select what tools should be applied at what stage. And now I'm super proud of having this team to be like in 20 members after almost 8 years. And this is generally what we do. We actually apply computational design tools, mainly with high qualified ones like AI and machine learning algorithm for decision making, because all we do is related to AEC and integrated engineering, which refers to using the perfect tool at the proper time, and that is related to what I answered the other question I was saying about if adaptive component inside Revit would work. And that was a nice question though. And now we use machine learning and deep learning for complex problem solving, which gives us the shot in our head that data is the most important part in any project, whether if it's research or professional one. So you're going to find out how today in this session. And if I want to talk about the first wing, which is the research and development part, we always try to do things with functional paradigms related to a deeper level of seeing parametric architecture. We have parameters, we have factors, and weaving these two, for instance, like getting to know what parameter from a structure would affect what parameter from environmental, aspects, needs a function between them. This is the whole deal in our R&D side. So we always try to find out about functional paradigms and weave these factors together between via the parameters among them. So think about it that way, and on the right side you can find a perfect diagram, which is above my head too, that gives us the path that what skills we should develop, and we can help you, any one of you, to ask after the session today, because that path can actually be unique for every functional designer, which is a vast and comprehensive stage for everyone, but making a true decision based on your background, your skills, your knowledge is the main problem. For instance, this is one of the functions that we found out about Iranian architecture, the traditional architecture. It shows how different load cases and load barriers can actually be integrated with reading the true geometry aspects and applying those loads on a specific lines. You're going to find out a more, light and more optimized design without any running of optimization algorithm. The functional paradigm is all about these kind of stuff. I'm super proud of our team in the research section. Let's find out about their, achievements in a glance. Yeah, I'm gonna go through this really, fast. This is related how to set up a node among different connections within a freeform structure, and how to use finite element analysis to find a perfect amount of material without any wasting part. And GNOP is related to a educational tool for how to deal with genetic algorithm and other optimization procedures. This is related to our Digital Futures workshop, which was trying to find out a way to use the patterns of geometry from Iranian traditional architecture and find out a way of using those patterns in freeform structure nowadays. And the next one is related to changing the whole resource from the last one to nature. And yeah, let's find out a way to learn from nature and write for it in terms of sustainable ideas that we all had in our minds. I know there might be so many questions about them, but don't worry, we're going to share this file with you, and just to find out a way how Ardana deals with different research aspects is another story, and you can reach out to us to find out about any one of them. This one is related to learn from nature by L system, based on 3 branches, and use them for developing a freeform structure by training a model in machine learning and apply it to our design decision. And the next one is also related to nature, using different patterns from nature and apply them to find out a way that our freeform structures can actually be optimized without running an optimization, but based on natural patterns. And the last one is here, which is related to how data flow from Physarium would work when it comes to defining some force flows on a freeform structure and apply that force flow as a pattern of injecting material on a freeform. So this one actually I'm proud to do because I was invited to sit next, and maybe we can continue on that if Hamid approves after the session. But the second wing, which we are here for today, is the professional side of Ardana, which is related to developing customized toolkits on Integr8.AEC using Python, C# and of course different plugins to find a way for complex solutions in industry. All the terms that we had in a Scottish Cube project, which was a showcase for us to apply this kind of, mindset on, is related to this part. CAD display is one of our toolkits, which is related to performance structures, and our recent developments through using a plugin for, data structure management in building industries, Data Hive. You can find out about this in a video which uses, cloud points, spatial space, and handling the file formats and developing STP files, which is the, demanded file in industry for producing a 3D object. And Data Hive gives us this opportunity to automate the whole process. And now in 2024, I'm happy about the changing of terms at the pro side at Ardana, which is totally converged into automation in AEC plus machine learning. And this is what we are doing at the moment. You're going to find out about some of these, efforts on a Scottish Q today. And please feel free to reach us for any enthusiasm or interesting idea that you have in your mind. We are super open to everyone. And yeah, that would be, make us to go through nice and mutual progression together. Okay, Lorelei Crystal is the one that Stefano also mentioned. We started on applying to different ideas that we had at the pro side on this one. It's a super complex structure with so many elements in spatial space. And we're trying to use different ideas, or better sense, automating shop drawings, auto STP files for the industry. And I just added this one here. So you can find out when it comes to developing a tool related to what the industry demands, you may just use 0.5% of your knowledge in computational design, but you need to know how to apply it. That's the case that we're going to experience today. And maybe we can actually have some time, or better to say, find a way to demonstrate how we actually approach this kind of stuff on Lorelei, but that's another case. Or if Stefano actually would be interested, we can run a specific workshop about this one after the project is finished. All right. If you want to find out about our current projects, just go through our website and click on the projects tab on the ribbon above. And you're going to find out about this and the stream and the workflows we're trying to, apply. Right. Let's just give the mic to Ahmed with this, question and answer. Ahmed, you need to talk to GH. Go ahead. And if you were interested in my, ideas, you can actually find me on LinkedIn. And I'm sharing so much awesome stuff about leadership in computational design community. You're going to find out about it. Thank you.
Thank you, Mahdi, for your explanation. And please mute your mic. I think maybe there is some. Thank you. Thank you for your explanation. And as always, you make everything easier to follow for me and make everything settled to start my presentation. Yeah. Just I want to start the process. We will go through the process in two sections. In the first section, I will set a bit of the process. And we will you can go through the GH script with me, and then we have a gap. We can have a short rest, and we have some explanation about the videos and all the process and approaches that we have gone in the Scottish Q. Then we will go for the second part and second part in GH script. So before I want to go for the Rhino and Grasshopper, I should just show that. Let me a minute, share my screen. You have my screen. Yeah. Yeah, okay. We have before I want to jump to the Scottish Q project. I should say may we are not allowed to share the main file of the main model of the Scotch with you, but we have a project here. It's named Project Spinel. That we use this one to showcasing a lot of it's a pilot project just to show different types of our strengths, skills, and even we can if we want to develop new skills in our team, we can use this. And in this workshop, I will use the same file, and you can find it on your on the Google Drive, the file, and you can use the model. Then if you have the model, if you have downloaded the model, you can go with me to put all the processes here and so on. So before and please download the file. I think it is on the, let me just a minute. Here it's, yeah. If you do not have the file, please find a link on the Zoom chat. Yeah, and I want to show how and what's the algorithm that we want to speak today about it. I think I should share my whole screen. Yeah, it's better to share it. Yeah, it's the algorithm that you can see that is about, I don't know, about is 1,000 and 400 components. That's it's about just one of the videos. It's part 5. You can see all the videos, and we will go through the process, all the videos and all the algorithms that we have done in Scottish Q, but it's just one of the videos and one of the algorithms that we have developed. Yeah, just I want to show what is the purpose of this video. You can see here, here it's just one of the spans. I can change the span here for every span that we have in the model, and for this span we can model. You can see it here. Let me zoom a little bit. Yeah, you can, oh, yeah, you can see that every elements that we have in those details in Scottish Q, we have modeled that all of them is parametric. For example, if I want to change the cap, I can change the cap here, and you can see that the cap is changed. And every single elements in this model is parametric, and we can change it. You can see that it should change all of them, and it's loading, and we will have another cap here. Yeah, you can see that the horizontal cap has changed. Yeah, and I think it's obvious that I cannot and we cannot go through all these algorithm today, the script today, but we use as an abstract one today together. I should assure you that if you want to do something like this, the main scenario is the same things that I will cover today, but it's in a more complex data structure. It's just the data structure, but the main idea and the main approach is the same. Yeah, in this, just before to go for the model, I should say that you can see here If I can show it, you can see that it's a bit heavy to load. Yeah. I should hide the shading here. The shading, yeah, yeah. You can see here, I have three different type of panels here. Some of them are curtain walls, some of them has opening, and some of them are metal sheets. So keep it in your mind, and we'll go for the model. And you can see, as you can see here, I want to start the modeling on this project. The project Spinel, as I said, is just the main model. I will use a line that we have here, and I will define it. The first step here, you can do this with me step by step, and as a showcase, as an abstract one, I want to cover a little bit of this process, but I should promise that it's the whole idea, and you should just use it in a more challenging data structure. If you want to do it, for example, for all the geometries, but I will just do it for this line. Here is the line that we have here. I should make some panels. So I need to, let me just minimize the zoom because it's bothering me here. Yeah, I moved it there. Okay, if I want to create some panels, I should divide this line. For example, divide the curve. So before I divide it, I want the counts. I use the length to make a proper one. Use divisions, yeah, and I will, for example, 52 meters, and I will divide it to, for example, everything that I want. For example, 100 and yeah, 114. You can see that. Here I have the number, and I can divide the curve as I want here. If you can, I don't know, in the chats, can I open the chats? If you want me to go up, can you, yeah, bifocal, I don't know, I have it or not. Yeah, I have it. You can, yeah, it's okay. Matty, please, if there's anything that I should consider, please let me know because I cannot see the chats. Thank you. Okay, and after I write the curve, I should create some panels. We should check this model again and again to see what we should model. For example, here I have some transomes, the horizontal one, I have some mullions, the vertical ones. So before anything, we can create our baselines as the vertical and horizontal profiles. Okay, here, yeah. Here I should use these lines and these points to create that. Okay, here I can use the points that I have as a sum line. I will use the SDL line. Yeah, it's use my lines. Yeah, here it wants us a direction. I will use the Z unit Z here, and it's on us a length that I will use it here as This project is 360. Here is the baseline. So here, I want to use, I want just before I model the main profile. We have, I think, thousands of ways to model a profile, a box. But I always use bounding box in these kind of projects because of two reasons. Because sometimes we want a box just as the one. It will give a product a lot of options to just want to change the geometry of things. Second thing is more simpler and is more how can I say it's not load for the system. And even if we have a longer process, but still by us, I think it's better to benefit use bounding box. Oh, okay, so for create a bounding box from these lines, just let me know. Here I want two vectors, one of them to the right and one of them to the left, and one of them is a prep on this line. So how can I extract this one? I use offsets. You can use some offset tools. Maybe you can use another things. I always use offset because even I have too many lines, offset can help me here. And for this one, if I use middle of this curve is the first point. And if I use the curve middle for this one, if I use vector 2 points in these 2 points, you can see here in these 2 points, I will have the prep vector that I want. Vector 2 points. You can see. Yeah. Just I want to say that reaching to this vector in your projects in different geometry, reaching a unique vector for each panel is something important, and the data structure that you can use for all the spans, all the panels that you want, you should use different vectors. Yeah, and here I can mark it here, so we use it hundreds of time. I want to use it. Yeah, the prep vector. And as I said before, we use two other vectors. Oh, I can use the same line here. It has some endpoints and start points. So I will use endpoints here. So you can see we have a point here, we have a point here, and we have a point in the center of the line. If I use the vector 2 points again, sometimes I will have one here, here is one of them, and the second one, let me just to exchange these two, and the second one is here. Yeah, now we are sure. Yeah, this one, the center point is the first point always, and the endpoints will be the second one to ensure that, yeah, we have one of them here, one vector here. And we can use these two, make it a group of this one, and name it, for example, L and R. vectors. As I said, this main line should have four different curves to create a bounding box. Here I use the bounding box. The bounding box here has two main methods, per objects or per union box. Union box means that we should, for example, if we have hundreds of lines or hundreds of trees, it will give us hundreds of boxes because we have 100 trees, because it will go for union. It will use all the box for the trees that you give it to the content. And if you want to just every little pieces as per objects, you can use the per objects, but we want to use the union box. Okay, for this kind of doing this, we should create some lines with moving. Here I can use a lot of here, and let me a minute here. We have these vectors, but it's not the same length that we want. And what we use always is the amplitude. Just it's use the vector here and with the size that you want, here and here. Or here, for example, I can move it on prep here. Yeah, this line here is our baseline. I move it on the prep with the prep vector. Yeah, you can see that the space is not as we want, and we can use here, for example, the here, for example, true. It will be one of the sizes. You can see, for example, I use 60 here. You can see that I have two lines on per rep for all the points. And then I move this one to right and left. You can see it here. Oh, like if I use just the amplitude is 5 centimeters, for example, just say 0 and 20. Oh. Yeah, here I use 2 digits for it. Yeah, you can see that it can move. But let's just see here what I want to do. As I said, we want a tree that's all of them has 4 lines in it. For example, here I have 39 lines. So I should have 39 trees. All of them includes 4 lines to give it to the bounding box to make our bounding box, or here the vertical profile. So as I can use here the viv, for example. I give it here, and this line, you can see, yeah, these lines, but it's all of them is in one tree. So what should I do is graft both of them. So you can see that we have 39 trees with 2 pieces. So what is the axis of the profile, not the 4 corners of the profile that I want. So I should use these 2 vectors that I have here. And here, let me, okay, here. We can move these lines. Okay, you can see it here. And even. And give it to John. Radius now. Well, let me a minute. Just change my connection. Now is better. My connection, I think, is better. Is it okay? Let me. Okay. I will go with a slow pace so everyone can follow my lines. Just so I can organize everything so all the guys can follow the process. So here I should say it again. Here you can see that you can move it, for example, 10 centimeters to the right and to the left. And if I use the weave again, you can see that I have 4 lines for the 4 corners of the bounding box that I want. Here I have the bounding box. So you can have change anything that you have here or even here. But because of that, these numbers layer is applying on the center of the line. You can see that if I use 10 centimeter, the whole width will be 20 centimeters. That's the same thing that I want, because the user cannot calculate that, yeah, every time, oh, what is, and divide it by 2, and for example, or multiply it on 2. But I can use here a division here and use it here. No, yeah, and it's divided by 2. Okay. Here, I'm sure that these 2 points are the space and the distance is 10 centimeter. And I am sure that, yeah, it follows the axis line. So I can organize anything here. It's, let me, yeah. For example, it's the edge, no, the vertical profile. Let me, okay, I will just let me a minute that I will want to review everything again for you guys. Just, yeah, let me label anything, vertical profile width, and is the vertical profile. Vertical profile, for example, the depth. You can see it's the depth, and this one is the width. So as here, I want to review everything that we have done step by step. We have a main line here as our initial inputs. Then I want to divide the curve as I want. For example, here I wanted, for example, about 100 40 centimeter, and it's divided to 38 pieces. And we have 39 lines, 39 lines. And then I create a line here with the points that I have here. Then I should create different vectors to create a bounding box to use it as our main profile. Maybe if you want to morph anything in it, or if you want to change the geometry, you can use bounding box because it's simpler to handle, because it's even have provide you a lot of options to modify your model. So I use different vectors. I create two vectors, the left and the right vectors, two here, using the center points of the main curve and the end points and the start points here. So you can see it here. Yeah, the start point and the end points. And the center points is here. One vector from here to here, one vector from here to here. And I have an offset here. With these 2 points, I will create another vector here. Just to mention that's how the bounding box is helping us. I want to say that even we have a project with Stefano, I don't know if he's here or not. We have here, for example, the bounding box is the profile, but in that project, the Katzenbach project, it is about a timber structure. We use this bounding box as the main substructure, and it has some horizontal and vertical substructure. And we use the same structure and we use the same things just to better to handle anything. Yeah, I hope that you are here with me. And then using these vectors, I should create some trees here with weave. I create 39 trees with weave, just with graphing these two inputs. I have 39 trees, and move them to the right and left as I have it here, and then create a tree with 39 trees. Each of them includes 4 lines as a corner of the pearl. Sorry for that. Okay, now we have the vertical profile here. If you have any question to ask until here, you can ask, but it should be a short question because then I want to go to modeling the horizontal profile. Let me open the chat. Oh. Okay, which one? What is what the input 0 of first sweep? Here, yeah. Here I use our main lines, guys. Here I use our main lines, and then here yeah. The first one, the 0 is this line, and the second one is the moved one. I can zoom a little bit here, yeah. You can see it's the baseline here, and the second one is the moved one. After the weave, after the weave, we have here. As you see here, I have two lines, and then one time I move them to the left, and one time I move them to the right. And these four lines will create our box. Okay, any other question? I can open the Q&A if you have any question. Oh, yeah, I will handle a file, the abstract file with you at the end of the session. But I prefer to have you all you guys with me to if you have any question and if you have came up with any other problem, you can ask it immediately and online. Okay, do you prefer I should go on, or if you want, I can answer your questions. Okay, if you have any question, let me net. I will go through the process. Okay, we have a vertical profile now, and I can name it, label it. Yeah, I can name it vertical profile box. Then, if you want to create the horizontal one, we should consider some other things. For example, we will use this vector, the prep vector again, but we should create another vector. Let me show you another vector. I can show you on the model. Please ask the questions, ask your questions, and I will try to take a look on the chat every other time that I can. Okay. Here I have the points. If I want to break this line to little pieces, I can use, for example, shatter. Maybe you have another tool to do that, or another components. Shatter is dividing the curve with the parameter or with the parameters that you will give it. I will give the parameters from these points that I have here. I will give the parameters, not the points. Keep in your mind that you should give the parameters here. Okay, we have 38 elements here. So if I want to create a profile from these lines, it will clashes with my vertical curves. What should I do is using extend curve. Yeah, extend curve here is you give the segments here, and the type, it should be line. And then you can, for example, use zoom out a little bit so you can follow anything. Just yeah, the shadow parameters is from here. When you divide your create, you can use its parameters as the input for shattering or segmenting your line. I don't know even we have segmenting as a verb or not, but it's okay. Yeah, then I will use, for example, number 4 or 5 centimeter, just as a sample to show you what's happening here. Okay. If I use here, you can see it's extend my lines, but I want to minus something, not extending as a plus for the line. I should make it a bit shorter. So I use here expressions, type minus and X. Consider this one. You can see, yeah, this number will be minus. Everything that we will give it as an input, it will be minus that number. Okay. And again, for both of them, even, for example, you can use negative here. It will do the same for you. There is no difference. And then if I want to, you can see, yeah, it make our line shorter. But you know, I should make it dependent to our vertical profile because it is independent and I should handle it manually. For example, if this one is 13 centimeter, if I make it, you can see that the line is doesn't changing. What should I do is here, I give these inputs to these two. Just let me show you again. From the vertical profile width, when you want to changing here, you use the division by two, the number divided by 2. You can use the same number to extend and make your line shorter. Here you can see numbers slider there. Let me change. All the projects, but little piece that we have in this project, Scott HQ here, for example, every single part and every single elements that we have here is dependent to something else, and depending everything should follow each other. For example, if you change any size for anything in this size, for example, if you change the profile here, this profile size here, maybe even them should be dependent. Can you hear me?
We can hear you now, but your voice is lagging.
Okay, I can change my connection. Do you have my voice clear now?
Yeah, but your screen is frozen. Guys, maybe we can take a 5-minute break. Maybe you can restart your router. Maybe that would fix the issue.
I have two different connections here, and I will check it both. I will check both of them here, and please let me know which one is better. Now, if you have, do you have my screen now? It's on ScottHQ, not the exercise file. If you want, I can turn off my camera. Maybe it's a better.
Maybe that would fix it. Yeah, I think your voice is fine now.
Okay, I hope that we do not have any other problem. If my screen is on the ScottHQ on the second screen, I think it's okay. If you want, I can stop and reshare it again. I will reshare it, and now I think you should have my. Is it okay? Do you have my screen now?
Not yet. Okay, now I can see the rhino and grasshopper.
Yeah, okay. As I said before, every single element should be dependent to other elements. If, for example, I want to resize this one, it affects on the whole model. For example, on this beam, or if I want to change this size, it affects on the transom that we have here, on the cap, even on the panel that we have here. So it's so important in these kind of projects to make all the inputs you have integrated together, and each of them should follow each other, because you should use some mathematical or logic or geometrical dependence to each element to have a rational model. So let's return back to our model. So here, as I said, you can see this one. When we change this one, is the width of profile, the vertical profile. It should affect the main line that we have for the horizontal profiles. You can see the green line is what you want. Okay, and for example, we have here as something rational is 8 centimeter. We'll get back on this line that we have. Okay, as I said, we should use this vector again to move it. The exact scenario, but with different movements. Here, and the vector, I should use amplitude again and use new number slider. It will be the depth of the horizontal or the transom profile. Just let me, for example, it will be in 0 and 20 centimeter. Here, here you can see we have two lines. And I think you know the end of the story. I should use the weave again. This line as the first input, the stream 0, the stream 1 is the second line, the moved one. Here I have, but it's not correct because it's all of them is in one are in one tree, I should use graph to create the tree that I want. I can simplify that so everything will be more clear. And then I should move it in Z. Here I use the Z units. I think it's clear. Just see here what I have done. I'm trying to make my pace a bit slower so everyone can follow me. Again, here, it will be the width of these lines. It is 0 now, and for example, I want to move it on 10 centimeters. I let us to and we can say, we can name it, for example, no, not this one here, for example. We can name it horizontal profile sizes. You can name it size A and B. Okay, again, you have the cheat sheet now here. When we move the lines, we should weave it again, all of them in one branch. The tree. So I can use the weave again. It should be the second one, and it should be the first one. So here you can see that we have the 4 lines that we want as the corners of the bounding box. Yeah, here, finally, we have the lines. So we can change the size and it will follow same. But there is something that is not correct here, that we have this one, but we do not have this one. I should move it to this level, for example, and I can move it a bit, for example, here. I can use the Z again, unit Z. And it should, as I said before, everything should follow our previous inputs. Here is where I moved and used these STL lines. The height of floors to slab floors, for example, here. I use the same thing for it here. Yeah. Here, it should be the second vertical that we want, and we can continue this line. There is some other details in this kind of situation, in these intersections in real world projects. If you want to avoid this one here, just as to look better, you can use minus. We can use it here, and minus subtract it from the height or the width of your profile. If you can give it to it, yeah, you can see that always it will align with your top of vertical profile. So here you have point, you have the vertical and the horizontal to horizontal and vertical profile together. And then after that, we can go for the panels. But here, if you have any questions, please ask. And I don't know if you guys need any break. We can, or a rest, we can use you can use your time here. Please write your questions or inquiries on the chat box. I will read them. Just here to make it full screen. Here, guys, you can follow the process. Let me just make everything more clear. I think you can see the process here. I don't know if you do not have questions. I can go for the panels, or maybe we can have a rest. I don't know, as you guys, and everything is fine. Thanks, God. Could you open the start and end expression in extent curve? Yeah, here. Expression is just minus x. Let me use, you can use the negative here, negative. If you use this component here, it will work for you. Yeah, both of them is minus x because you want to make your line shorter, not longer. If you want to make it longer, yeah, you should use some positive numbers. If you want to make it shorter, you should use some minus or some negative numbers. Oh, this subtract. We have two inputs. One of them is the height of the slab to slab, as I have here. You can have it, you have it here, 3.6 meters minus 10 or 9 centimeter here is the depth or is the width of your profiles. The inputs of the extent curve, you mean? If you means the extent curve is from here, it should follows the vertical profile width. It should be dependent to each other. Where does the vector input from the first amplitude command? The vector input from the first amplitude command, which one? We have three vectors here before the amplitude. I don't know this, if you mean this one, it is the same one that we have here, the prep vector. I use the prep vector. As I said, that this one is something important that we should use it all the projects because we want some guidance or some guide lines or guide vectors for all over the projects always. I don't know. Can I attach? Can I attach something into Zoom chat box? I don't know. If I can, please let me know. I can make a screenshot for you guys. Okay, I will create a screenshot now. Save it. PA workshop. First, let's see. It's now 7. Screenshots. You're welcome. Just let me. Where is that? Workshop. I think it's for you. I'll send it here in the chat box. While it's uploading, I hope that the connection will be stable to set everything up. Yeah, you have the image. I think it's a good suggestion. Thank you, Yasaman. I think, yeah. Thank you, Yasaman. You're welcome, boss. I know that you will say that I'm not the boss, but you are. Okay, guys, do you want to continue our process, or if you want any rest or taking a sip of water? Oh, regards, George. Yeah, I think you are always continue. You are a hard worker, as I always heard from Mahdi. Okay, I can continue if you want. Yeah, we can go through the next part is the panels. Just let me, I do have my screen. Yeah. Okay. Let us to create a scenario for the panel that we want. Here, you can see that I have a lot of panels here, 38 panels. But for example, if I want to use some glazing panels here in points that I have, for example, columns or walls or these kind of things here, I think it will be met. We will have some clashes here, and I think it's not okay that we have here. So first thing, you can use this kind of reps as our input. But what we have in Scott HQ is some concrete walls. Let me show you what we have as something here. Let me just here behind these metal sheets, we have some concrete walls that's it is exactly, for example, in this project, we do not have, for example, concrete walls. Here in our project, on these spinel projects, we have the columns, but here we have some concrete walls. Let me just show you the structure that we have here. Yeah, just I want to turn it off. Yeah, you can see these concrete walls. These walls are some concrete walls, and it is the points that we should have some metal sheets. Okay, the equivalent for us in the spinel, we have some points like here. Yeah, we have some points that we have some columns here. Okay, we can give these columns as our outputs. Oh, sorry for that. Okay, I use brep. Oh, let me type it. I cannot find it. Brep is here. Shit group is the horizontal. Do not forget it. is our BREP here. So I should multiple BREPs, this one, or this one, this one. Okay, I have all the boxes here. When you want to do these kind of things in large scale with hundreds of objects, and you cannot do it manually, I always use elephants or even Launchbox. For example, here just I want to show you that how it's work. For example, the reference that we have in Launchbox, you give it the layer name and it will select all the geometries or all the objects that it will be on that layer. And even in ScotHQ, I use the same thing. I use the Launchbox, and it will extract all the objects in that layer and give it to us as an output that we need for rest of the process. Okay, we have this point here. Just keep it in your mind that we have some points that we want some metal clashing on it, but I do not have any surfaces here. So I should create some surfaces here. I will use the same lines that I have here. I think it will be rational for us because here is the exact line that we want for a panel, but the location is not okay. I should move it a bit further. And extrude it to these points. You can see that I should make it dependent to the sizes of the profile again. Okay. Let us extrude it to the Z. Extrude it to the Z. But here you can see, but what it should be the number or the number for extrusion. I should say that we should make it dependent to this one. If we make it dependent to this one, you can see that, yeah, it should move it from here. It should extrude it from here to here, but it's not correct because the panel is clashing with this. So I should move it before I extrude it. Here, I move it 10 centimeter, or I don't know how many centimeter. Yeah, here 9 centimeter. Make it. It's not correct. Yeah, this one. The motion. I should have a unit set here. Connected to this one. I know that's maybe it's gonna be some confusing process, but just follow what I'm doing. Here, I should move it, but how much centimeter? Here, it's just 10 centimeter. Or I don't know, 9 centimeters again, I forgot that here. And then I should extrude this one. And this one, it has some clashes with this one. And I know that I should make a subtraction again from what I have here and subtract this number again from it. Just let me to review anything again. I have a main line here. I know that the location, oh, sorry. I know that the location is not correct. I should move it I should move it by the width of or the thickness of the horizontal profile size. And when I move it, I should extrude it. I know that if I extrude it, if I want to extrude it, I should extrude hold the floor to floor slab. For example, here is 3.6 meters. I should subtract it from 2 multiply the width of the horizontal profile. And this one you can see here. I have the number here that I've moved the horizontal profile, and then I subtract it from the width again to have the proper extrusion. So here I have all the panels. I should just handle it to two sets of data. So, I should have some of them as windows or some curtain walls, and some of them as metal sheet to cover the clashes with these columns. So what should I do is I use closest points. Let me close this. Point, not this one. Okay, then I can use this one. You can see the center points of the panels, and I should have the center points of the B-reps, the columns here. Okay. I have 8 points that I want to create a set of lists. For example, here it will use the 3 indexes that's near these points, but I do not need 3 points. For example, 1 is enough, I think. 1 is enough. Yeah, here, for example, this one will be metal sheet, this one, it will be metal sheet, this one, all of them will be in a new list. Okay, what I can do is use list item, use the indexes here, and my list is this one. You can see that these panels will be metal sheets, and the rest of them should be other materials. For example, here, the curtain wall. I can use move again just to show you here this panel is sticked and aligned with the start points, but I do not want my panels here. For example, I want to move it in the depth of our profiles. Okay, I should use the move, use the same vector, the prep vector that I have. I said that I should use it hundreds times in a project. Oh, what's happened here? And even just I can use a different number slider for that. 0 and between 0, for example, 9. It's okay. Here, this one, for example, maybe the metal sheets needs another specification to being in the profiles, and even I can copy this one for the curtain walls. How I want how I can extract the curtain walls. Here I selected these indexes. I should create a leaks with call pattern. I use call pattern. Oh, not call pattern, call indexes. This one, call indexes. I have these 8 indexes, and I want to call it from this list. You can see, yeah. For example, just to show you what happened here. This list is the indexes that should be metal sheets. And one time I should, oh, this one is not correct because I should flatten it. Yeah. One time I call it with C-U-L, not C-A-L, call pattern. And this one should be the glazing panels. I can make it an offset. You can use the offset from pufferfish because it will create for you some solids. And this one, for example, should be 2 centimeters of panel. It will be our glazing panels, and this one can be our metal sheets, for example, with different here the metal sheets, and we have. Let's make everything a bit better to preview. I should preview, set these preview offs just to create custom preview. The metal, I will create the metal, some red, for example, colors, swatch. Color swatch will be red, for example. To have the metal sheet as red panels, and here have the glazing panels as some blue, for example, blue, and make it a bit transparent. Yeah. Make it more transparent. Yeah, it's okay. I can make these things here. For example, gray. Yeah. And here, the vertical ones should be here, and for example, should be black. Okay, you can have your model. You have a curtain wall with different options to move everything. For example, moving the metal sheets in the profiles, or even the glazing, changing the sizes of the edge or the horizontals, the size or the depth of each profile, or even here. Okay, you can see I can limit that to 2. I think it's okay. And the depth will be here. So even I can make it a more limits. I can you can see everything that is changing here. Even I can change the sizes of panels. Everything is changing. It's the same scenario that you can see in our CottageQ videos and processes. I think it's enough for now. I have some other parts to model, but I prefer to Mahdi have a explanation on all the algorithms and data managements that we have done on the Scottish Q projects. Let me turn off my video and stop sharing. If you have any question, you can ask it now. And then we can go for Mahdi's presentation on what we have done in Scottish Q. Guys, I'm here to answer your questions. He takes the proofs from the global and the centers of them and panel on the closest point. Then he takes use the list items. Yeah, because closest point, what closest point is doing for us is I know maybe it's a bit new for some people, or maybe new in Grasshopper. It take some points, for example 8 points, and we have a cloud of points, for example here 44 points, and I said that in each points from these 8 points, please find the closest point to these 8 points, and it will find the closest points to each 8 points that I have. For here, I said 1 point. If I make it 2, you can see here we have 2 points. Just to make it show you here, you can see that the 2 points or the 2 panels are near these points will be metal sheets. And even if I make it more, it will be, for example, if I make it 3, you can see here, this one have 3 panels near it. It will make it metal sheets. Okay, answers question. Can you or do you need attach data elements for detail reference, for example? I don't know. I exactly got your question, but if you want to add some attributes on points, we can use some, for example, elephant, or even I know that at TT Toolbox, you can add some attributes to each element. For example, this one or this one, you can attach some data, bin data on it. You're welcome, Vani. And brief explanation about how weave components was used. Weave components is, as its name indicates, it's weaving data. We have some data and it will make it together, weave it together. The inputs is some patterns. The default pattern is okay for us now because it's use first stream and then the second stream. We can make some changes in the pattern, but what we have here is that we have a stream with 2 lines here, and we have a stream with two other lines here, and we want to make all of them in one branch, and you make it union to each one, and we weave it together. And please, the recording of this session, I think you can ask the guys, Amr, Hamid, and I think you can have it on YouTube, and even I think on PA websites. Andrea, you're welcome. And do you happen to have any material on this? If not, I don't know what's your... I don't know exactly what you are meaning, Danny Adrian. Oh, tutorial on do. And no, not yet. We do not. But we have. I don't know. I should ask Mehdi. Maybe we have. Please reach out to Mehdi on LinkedIn. Maybe he can answer this question. Okay, on the previous question, attaching data to elements. Yeah, we can attaching data elements with elephants. Okay, you can reach out with Mehdi. George Pasik, I think. Yeah, thank you, Mehdi. You're welcome. I think Mehdi will answer your question. Okay, if you have any other question, guys, I can. Yeah, I will give you some screenshots from the script, and I will send a more complete and more proper script here that have here. You can answer. Just stop share. Do you have my? Yeah, I think you have. Let me just show you. I will send this one for you. It's a bit more complete script because lack of time. I cannot cover all of them, just to show you the script that I will send for you. Yeah, here. Here with some other elements. For example, the beam cantilever beam, the walkway that you have here, and even some different shading patterns. You can change it. It's a bit playful. Yeah, here. For example, you can change the here, yeah, rotation angle here. I will send this script for you guys, but I think we do not have time to cover all of the process. But if you want, and if we have time, I can just explain what we have done, because we cover these two groups, the panels and the profiles. Okay, Mahdi, I think we do not have any other question. Let me just check it again. If we do not have questions, I think we can go for your presentation about what we have done in Scott HQ. Yeah, Mahdi, mic is yours.
Hey, thank you, Ahmed. I was in the chat box.
I
Oh,
saw the
good.
fire that you have set on the chat box. Thank you for supporting me.
You are welcome. Okay, let me show you my screen first and talk about what resources I'm dealing with here. You should be having my screen in a second. Is it fine? Right, thank you. Okay, the project that you were working on at the recent section by Ahmed is project list me now. I explained a little bit in the chat box that we use this as a showcase, not a showcase, but more of a pilot project to extend our own skill set at the office. And from time to time, we challenge ourselves with different, kind of facade systems. As you can see, we have a freeform here. We have GFRC, which is related to glass reinforcement concrete panels, something like that. And the glazing facade are different kinds. And just go through our website and check out the different details that we've, designed so far. Like this one, which is amazing to follow how we deal with different, facade system and everything. And you're gonna find the exploded views and how our guys at the technical team take care of the, every little piece of every system. I believe our designers need to know how to deal with these kind of stuff. And this is not just all about having, perfect shape. Sometimes it is about the technicality behind the whole thing. You need to know about the facade system and how they work structurally, environmentally, and of course, aesthetically. But most of commercial designers, take care of the aesthetic part. However, when it comes to real projects, you need to know more about the structure, system, and everything. And for instance, this one here is related to the freeform part of the system you've been dealing with during this, a specific workshop. Once you click on, the other side and the tabs here, you can find out every little piece, the connection to the concrete, the connection of the main system to different elements like the bikeway here, the cable system that holds the, strings of the second skin. And you can find these kind of stuff in, real world applications of dealing with different material, detailed design. And you also need to know about how compositional design can help us to go through these kind of stuff. Okay, you can also find the ESCOT headquarter page under the projects here, and check out all the videos I'm going to share at the moment. And some of them are under these tabs. For instance, when it comes to facade and design space and surface analysis, cost time management system that we use Grasshopper to deal with, and building environmental factors that some of you guys were interested in. And of course, this one, which is the, one of the most important one related to the detailing, parametric detailing, which is the main idea behind what Ahmed presented to you. And of course, some of the integrations procedures that we actually face when it comes to handling a complex real problem. I mean, in this project, we use ArchiCAD and GH2D integration, which doesn't work that much properly, but we use this because the client wanted it. And okay, let me just walk you through into videos from one to one to check out what were the difficulties for us as computational designers and how we dealt with the whole stream of problems. So in this one, you can check out how we actually imported the different layers of the floor plans, and how we used, different scenarios like opening the metal sheets, the glazing parts that you actually, learned during this webinar, and how we try to settle them from the floor plans by the objects. I mean, for example, the hatches were important into Grasshopper, and we wrote an algorithm to find out the hatches, the doors, the windows, and try to, extrude the proper material, or better say proper, face that you can see here: metal sheet panel, curtain wall, and window panel. And the algorithm was kind of intelligent enough to find out which elements of the floor plan work, and it tries to produce them by the material we wanted. I think Maurizio asked about the adding attributes, and that was a little part of this process. Developing such things could be applied on the other floor plans, and you can easily find out with one script inside Grasshopper, we could manage the whole system because it, panelization of the process and at this project in different levels were different, were randomly. And the script could actually find out which part should be metal sheet, which part should be the glazing. And it was also intelligent enough to extend the floor plan in every little, side to be followed by the same logic. And as you can see, this is a dramatic change like this, changing the elements of the hatch, and it could find out the new, iteration with the updated data. So I don't want to, have this too much. Let's just go through the advanced mode of what we've trying to, make you understand about scripting a process related to, a facade system. In this case, we have this frames with the mullion, transom, and of course spandrels, and every single one of them is parametrically connected to the whole project. And this little guy here at the forefront is the main sample. By changing the parameters on this, you can apply all of the changes on the facade system at the back on the whole project. Right, that was, the first one, which we call it parametric modeling from 2D to 3D. And this is one of the, greatest idea that you can actually deliver as a computational designer when it comes to, having a floor plan and want to build the whole project at once, but based on some logics. The second one is related to, let me just show you the whole algorithm in this part, is related to surface analysis, which includes how much glazing we have, how many metal sheets, live BOQ, and typology of every single one of them. At some point at the, coordinate system inside Rhino that you can follow. And this is, related to even the cost and time. And of course, it also represents the errors in your design system. For instance, when it comes to divide your floor plan into different sides, different segments, and if your segmentation is not properly related to the facade system products at the manufacturing section, it's gonna be giving you an error inside the algorithm, and you can find out, okay, I need to change, for instance, this part of the project. So reading the floors is now really easy with some line of code inside Python. And scenario. Okay, within the next section, do you have my screen now? Oh yeah, let me just go for it. Okay, great. At this section, the algorithm tries to generate the facade on every level. And then it's comes to change the number of segmentations. Eventually, we're gonna add the second scheme. But before that, we need to control the segmentation of every little piece on a floor plan. Based on the architectural space, we can actually divide different segments from one column to another, and it was, related to parametric scenario. Let's just dive into the second scheme and have different scenarios for them, totally related to the main project as the picture shows. You can now check how these, revolving are being done, and within the environmental sections, we actually connected this part of the project to solar incident analysis to find out, okay, which angle of the second scheme works better. And now we are going to running an analysis related to the topology of the facade system. And you can check each part is labeled and of course automatically, annotated. It's easy to follow for you. And when I change the material, the whole demonstration will be updated really easy. Let's just go through the metal to glazing and to openings. The typology also has been applied. And now we're going to have a live report beside our main project. Let me just show you here. This table, the 3D table of opening frames, 168 total pieces in 26 types. And if you select one specific type, for instance, in this example, we have selected type L. We're going to know that we have 37 of them. And the location of them also is colored. For example, this is on L, 37 pieces. I changed the name type to another thing. For instance, A, and now everything's updated. We have 18 pieces. And when it comes to having a billing of quantity, BOQ, you can easily find a way to have these reports added Grasshopper. That's the most, powerful side of GH. So it's not just about having a cool or, complex geometry, but sometimes it's about having something visualized for the architects, the contractor, and for the construction site so they can follow, or better say, to make a better decision. And think about it when it comes to adding custom time, and the most important part for project owners is these two kind of stuff, and you can easily follow this. If you are curious about the side panel that represented the data, you should go for Human UI as a plugin for Grasshopper. It's wonderful. And let's just go further with every type on a 2D model and how many pieces we have from them. Type S, only one piece. That's a problem for this design, so we need to change it. And now this is all about the reports that we got from Human UI related to every piece or every type we have as a facade system. We also have the overload work per type, and at this part here, down on the reports. So we can find out which type takes more time to manufacture. So they can actually, that's the exact part that I was trying to say, that decision making process based on what your algorithm gives out is really amazing and of course reliable. These are the exact panels, like the K type with 6 pieces. And you can find the different also, where they are located, and the flag panels with just one type. For instance, the general metal type, the L type, has the most pieces. And maybe you can actually, give them some notion that, all right, let's just go for the L type to be produced first. These are the decisions that connects our mind as architects and construction designer to the construction site and of course the manufacturing procedure. All right, this is the next part for the cost and time. And just so you know, there are some standard width and standard heights in that need to follow as designers. I sort them out here in these two is make a comparison steel A plus, steel A, steel plus, and we want to check out which is, for
Matthew, can you hear
example,
me?
the perfect. Yeah, do you have me now?
I think we lost almost like last 1 minute.
Okay. Let me
See
just
if we
go.
can go just 1 minute back.
All right. Is it fine? I was trying to demonstrate how standard width and heights can actually be applied on the project. Did you have this part? Okay. Can you guys hear me?
Yes, now we can hear you.
All right, great. I was trying to let me just start this part. For every facade system, you're gonna have a standard width and heights for the elements. And right now at this part, the algorithm follow those standards and try to find out which part of your design at the real project you have on the screen is over and give you some and it gives you some decision making idea that you need to change your design, which is parametric and easy to follow because you're over the standard dimensions. So let's just find out how it goes for it. The Python code runs a really simple analysis with the height and width that you have on the project in this iteration within your design, and it tries to check each with the profile system, a standard profile system that the manufacturer will offer the project. In this case, we used Shoko as the FWS, which is one of their system on Facade. FWS 16, 15, and 35S. You can find the catalog on the website. And with selecting the material, all right, let me just change my okay, I changed my internet connection. Hope it works. And someone approves me about that. David, the facade system is the name and the company is Schuko. Schuco. Okay, you probably should have me by now. Guys, can you let me know if you have my voice?
I think you're cutting off a little bit. We can hear you time to time, but I can also see that, yeah, 10 seconds, 20 seconds in between, it's cutting off a little bit.
All right, I'm gonna continue. If something comes up, just let me know. I don't know what's going on here. Okay, I was trying to set some stuff related to material selection, related to glazings. The glazing pans are sorted, and the designer can actually select them from this panel. And once they select each that they want, the price and of course the weight of the panel would be added throughout the whole workflow. Let's just dive in the visualization part, which is more solid to follow. Okay, in this section, you can find out we added the curtain wall glazing systems, prices and weights. And once the designer select their perfect material for their system, like the profile they want, the system they want, this sheet at the right side will be updated automatically based on the parametric model that you have. You have the transoms, mullions, and the system here. All are added. And one of you guys asked about the system names, FWS16, FWS35S, FWS15. These are, just randomly from the Shoko catalog. You can find this on the website. Just let me know if you had problem to find those kind of, documents. And for the glazing attributes, or better say glazing pans, we have different parts, like single 6 mm laminated is the one that we chose for, the study facade system. You can add as many as you want, like different systems, different companies, different material, and find a way that's how your decision affect the cost time of the project. Now at this point, you can even find the errors of the design, and the algorithm will give you the most challenging part of the system that you chose. So as a designer, as a computational designer, you can easily find out what decision that you made impacts the most at the project. And you can change the whole thing because everything is parametric. And just think about how organization can actually, improve the whole system here if you have enough resources, the great configuration of a system that can actually, run the whole thing because it's gonna be huge. This visualization shows how different decision, or better say, how different types give us the most errors of the design. It's not that, you know, something critical, but you need to consider them. For example, the type E causes the most of the problems. So you can find the type E and change its size or customize it. Where is it? Where are located project, and following them on the whole system is that hard as it should go before. Like different clashes, different, you know, errors, like column grid clash or sequential clash will update the whole thing again for you. Right, in this part, we're gonna mark the most challenging parts of the construction process. We call it constructability, which is one of the most, you know, pivotal parts of any parametric model if it is connected to construction attributes. For example, when it comes to more customized types, the construction scenario would be more difficult to follow. So if I locate them, the challenging part of the facade, we again can actually help the contractor to find out a way for managing the whole project as in the construction site. So let's find out which part is the most challenging. Look at these kind of, you know, red blob. They actually how many hours are going to be overload, how many dollars are going to be added because of your design. And this is really interesting because the time load and cost load of errors can actually be, you know, followed up, and you can easily understand what kind of decision you make will add the cost and time to the project. So when it comes to decision making, the contractor, the project owner, and you as the functional designer can find a solution for this stuff. But now we actually made it dramatic change again here to find out if algorithm adapts the whole thing and from, you know, 0 to 10 with all the steps that I talked about. Again, the change actually has been added. Right, let me just go through this part, which is highly important. It's not it's not parametric, but it's related to the amount of knowledge you need about a facade system when it comes to design them. So architects do not know about this stuff, or it's better to say that they need to know when it comes to designing a facade. And you can find out that every little piece here has been modeled 3D in Inventor, Autodesk Inventor. This is the software that I'm talking about, and you can easily find out every little piece of a Scott HQ project is modeled from every fastener, every bolt, every little piece, and of course, you know, all the layers of insulations. It's a fantastic video for architects to find out. They draw a line on a piece of paper when they want to be creative, how many or elements are going to be added to the project, and how we can actually manage them through to have a better decision. That's why optimization procedures are always, you know, important to follow. Now we have the shop drawings, which came out really easy out of Integr8. And you can see how these elements are assembled. This is one of our, favorite services that we deliver for the installation video. So they can actually find out how to assemble each element. And I rethink about it. This is a freeform structure. You want to have something like that to find out a way for assemble every little part. The sticks are added, the walkways, the panels of this panel part, and of course the second skin, which you're trying to model with Ahmed's script, but in a more advanced way. Now, we actually find a way to produce these metal sheets totally ready for manufacturing process with all data and the 2D, files. Yeah, I want to skip these parts because, like, more related to how to develop sheets and shop drawings. But all of them are automatic inside Inventor too. And that's really the interesting part of working with such tool. And these are the, outputs. Okay, that's cool for now. Let me just, show you the final part, which is I think this. And Ahmed will cover his own part, which we always call video number 5. For you guys that's were interested in sustainability, environmental part, we have a local team led by Mohammed Muazzini. He and his team work on this part using different tools inside Grasshopper like Ladybug and Honeybee to find out a way how solar incident would affect the design and how we can manage this through, different scenarios throughout a year in every little hour and to find out a way how design can actually be adapted more to the environmental procedures. All right, here you can see this solar panel and which shows, the main important hours of the year that the solar incident would be raised up. And now we have the butterfly effect of the shadows, which shows, the perfect amount of different buildings at your site that would affect your own design. Now we're going to have the whole process on the facade system to find out a simple, or better say, a simple one as a sample zone to check out how much carbon would be produced within this design. It's really interesting how much daylight would be go through or penetrated through the design aspects after your second skin. And every little part of these kind of stuff, which requires, so many back knowledge, that it's not my expertise, obviously, but they all affect your design decisions. This is the beauty of parametric architecture. You find a way to check every little piece of your decision-making process of your design iterations with different aspects like environmental, structural, checking the constructability, the load of the cost an hour that would be, impact the construction side. All of them together in Scott's headquarter building has been done as a showcase to, demonstrate how computational design can impact the building industry. And this is what we are going to, or better say, we always accentuate in these, workshops, because We need more people to take things together as different workflows should be adapted to the building industry demands. And we need more hybrid people, as I always say. Okay, that's the whole point. I don't want to, talk too much. You can find every other piece of these videos with descriptions and captions on our website. And ID partners, I need to thank you guys because you give us, the access to this project and to find out a way so we can work on this together and to, show the whole workflows to the community. That's actually very interesting. And it was, PACE, they're always going to be referred to for starting our collaboration after Scott. Okay, thank you, Ahmed, for sharing the links. Yeah, and please accept my apologies for the back and forth disruption of the internet connections. I don't know what's going on in the country again.
Video, we have some questions. Please, if you can answer the questions.
Okay. The first one is the anonymous attendee. When and how do you trim the curved bottom of the curtain wall facade? That's an interesting question because it was related to the architectural space. And since the architects wanted the curve to be the curve, not an end segments, we find a solution to adapt the facade system to what they wanted to add, as the units. And for example, finding a proper segmentation between two columns at the corner of the project, which gives us the curve line, totally aligned with different, column that we have on the straight lines of the whole facade was the main key. And just segmenting the length of the curve is not the proper solution. So you need to find out a way to control this to be adapted. Oh, okay. Through the video, you're gonna find that when I change the parameter, the number slider of the segmenting procedure, the whole algorithm will change the straight line segmentations too. So these two are working together. All right, the next question, how long did all this consultancy take on this technical designs and what was your participation later during the construction? This project is our showcase for starting, the whole thing as that, all right, computer designers can actually deliver these services to you. I'm talking about the clients. And we actually added as a computer designer team after the project is built, right? Just keep that in mind. We're not showing our work related to what has been built. But after it is built, we and IT partners have started to think about, oh, all right, if we had computer design tools at the time the project was being building, how actually would it be, and how we could actually apply these things to the whole thing. And about your first question, how long did you almost I'm at 6 months to have all these kind of stuff running, or 4 months, something like that.
I
It's
think,
not
yeah, we have started on August and we have completed all the parts on first days of November.
okay, almost 3.5. And this is not our work. It's a teamwork, all right? Okay, Amit, do you want to read the questions?
I think you're going through them
Alright.
quite Good. So, well,
Okay,
good.
Sark,
If you want
take
to
your part
continue,
too.
yeah.
All right, what plugin do you use to make the data visualization? Yeah, that's a good question. Go for the human UI. If you are going to use it on Rhino 8, you need to have the latest version. And just to remember, if you're going to use it on Rhino 7, you need to have the second to last. I cannot remember the number of the version, but it was the second to last version. Yeah, I can, check and give you the exact number. May I ask, for non-uniform and double curvature services, how do you normally resolve this? That's a big question. The most challenging facade system you need to take on panelizing, we call it, are those non-uniform and double curvature. I don't have a prescription for that, but from one project to another, you need to find a great and rationalizing process for your panels. That's the case. Just to explain it a little bit better, think about having a double curve with a footprint of basic geometry. Like the basic geometry is triangle or is rectangle, but the form of the double curve is different. It's another story. It's another story. But when it comes to have a free-form footprint, we have a project about that, and it's gonna be something else. Okay, so from one project to another, the solution that you're gonna use about it, managing the double curvature, is gonna be different. And may I ask, okay, that was written already. How many people was full-time involved? Almost 1, 2, 3, 4, 5. Ahmed shows me 5.5. What was the half? 6? Oh, okay. I couldn't find out your finger out there. Right, yeah, 6 people about managing the whole thing. What's all the fabrication drawing generated in Inventor? Not specifically, but the system, the installation drawings of the system, yeah, it was added in Inventor. But we find a way after that between Python and Grasshopper to automate the generation of the shop drawings, and you can share some stuff regarding that on Lorelei, but not now. It's a bit confidential. Not from our side, I mean. But yeah, some part of this related to showing the whole system and how it works was generated in Inventor. My last question was about Scott HQ. Okay, what was your last question? So profiles are modeled as boxes in Gauss. Oh yeah, I remember that. Okay, the boxes and the actually cross section are applied in Inventor. No, we use the bonding boxes to make 2 things. One, playing with the planes of the element that is in a spatial space. We do not know where it is located and how it is, located in a spatial space, but we actually have this somewhere on a structure, and we use the bonding box to find it out. But imagine if a box that includes the element in a spatial space, it should have the best box that it can actually include it. I mean, no waste of the volume at the spatial space. So for doing that, you need to have the cross section of your element as the main plane of your box. Once you have this in a spatial space, and you have your cross sections rolled down on floor, or better say the XY plane, you can mix and match these 2 together, and the spatial one will read the one that you have on the ground. So there shouldn't be any concerning process in your mind that these 2 are not mix and match, and that would work. It actually also applied in a Scott HQ when it comes to, moving along with the line of the facade system. That's actually a trick in using Grasshopper. The vector of your facade is going to change. For instance, this is the face, it is revolving, and the vector is going to be changing all the time. So by tracking this vector and having this as the plane of your box, you're not going to lose it anyway. You know, it will revolve and the box is revolving. So you're going to find a way in that case to, you know, find your cross section totally revolving as your facade main line is revolving. Okay.
Thank you, Matthew. We have a question from Honor in the chat, if you can read it.
Yeah, go ahead. Oh, that the longest one. Question
Yeah,
connection
I'm
vertical and horizontal profiles aligned with the connection elements to integrate the structural analysis process. This might help us analyze and decide the limitation of cross sections. How can we move this parametric geometry modeling to maybe current maturity to achieve this? Okay, you know, the trickiest part of using a structural analysis, as far as I know, is to have a linear model for your analysis part. All of these structural analyzers need the linear model. No matter what the cross section is modeled or not, you need to give them the linear model of your model. All lines, nothing, you know, particularly 2D models. And then you need to, you know, redefine the cross sections inside current maturity. And managing this is a little bit hard, but it's not impossible. When it comes to model this, the whole facade system, like the one that Ahmed told you and try to demonstrate, the output model is not well prepared for current maturity to be applied, okay? Because the modeling system of a structural analyzer is different from what we've done, you know, in this section. But I can talk about this till morning, but you know, it's a little bit complicated than that.
Matthew, we have another question from George. If you can.
The connection details between the profiles have been modeled in Rhino. Some part of this were modeled in Rhino and Grasshopper, but the one that were related to the installation drawings were totally in Inventor. Ahmed, can you show the main algorithm again?
Yeah, sure. I can show the video. I think the video can give us a better understanding on what we are doing. I think this video. Do you have my screen now?
Yes.
Yeah. Okay, it's as Mahdi said, we use the inventor model for the installation drawing and these kind of things. But we have another algorithm that we name it step 5. That's to parametric detailing with some libraries. You can see that there is each group that we have here is representing some elements or some objects in the model. Do you have a voice?
Yes, I can hear you. Yeah, I can see your grasshopper and
Yeah.
on the screen.
Yeah.
Mm-hmm.
Yeah, this one, we can see that there is a lot of elements here that is modeled, all of them in parametric way. And in one span, you can see that you probably model. There's the concrete slab. These are the connections to the slab. That's how the vertical profiles is connected to the slabs. It's parametric. We can change all the things that we have. The sizes, the hole, the number of the holes, the size of the holes. And yeah, George, your question I think is here that how we can how is the connection and the intersection between the vertical and the horizontal. You can see that we have a joint here, the red one, that it's between and we have different kind of sizes and parameters changing. You can see that. We have added the horizontal ones. You can change the profile from the libraries that we have with different caps, horizontal and vertical. The space that we have in different caps for the cantilever that we have for the second scheme, you can see there you can see that first bars, that's everything is here is completed to be parametric. See, every elements have some parameters to change, and this is the cantilever beam that you can use for the second scheme, and these are the columns and the metal sheet here. You can, as I said, all of them are dependent to each other, as we have in our hands-on projects today. And lastly, different type of panels. You can see here, for example, if we have different type of panels, how it should be applied on the model. You can see the walkway that we have, the spaces, everything is parameterized. The spandrel for the second scheme and the shading that we have. The different alternative that's the clients needs for shading, just showcasing, as you know, yeah, different type. You have this type of shading on the completed version that I have uploaded on Google Drive. You can access it on Google Drive, and the guys can send it to you and share it with you. Yeah, you can see with changing the parameters, and this one is another alternative for shading. And yeah, that's it. And with changing the number slider of the spans, you can have the same parts and the same elements, all of them parametrically, auto-generating all the spans one by one. You can see that if we change, for example, this one to second span, first span, or even number 10, you can have it on all over the projects. Yeah. That's it. And you can access this video in our website. And even if you have some crazy changes on the model, it will be, if you will compute it, you have all of the changes on these footprints. Yeah, that's it. As I said, it's 1,400 components, and it's not even rational to teach it in one hands-on project. Just I try to teach that what is the main things that we try to handle in these kind of projects. The main vectors, the main planes, the main structure, make everything dependable with some mathematical or geometrical rules. Yeah, that's it. Thank you. And if you have any questions,
Well,
I'll be
thank you
here
so
for
much, Ahmed and Mahdi. It was incredible session. It's mind-blowing how detailed you guys have worked on these projects. And 1,400 components. Wow, it's incredible.
It's just
So
one of our algorithms. I think Mary have 3,000 just for that spaghetti with all the
yes,
wires that we have, all crowded wires there.
yes, I can imagine. I can imagine. Well, I don't know how to thank you guys for showcasing all these detailed works. And 4 hours straight, we've been showing what you guys have done before. Well, I appreciate your time. Thanks for everything. And yeah, I think we're almost at the end of the session. And as I stated before, the video on YouTube is available. The high quality version will be uploaded to our website. So you can have access, which is a free access. You can have access. You can go and watch it. And make sure you can check the latest course and upcoming courses that we have on the Academy, as I'm just showcasing right in here. Okay, make sure you can follow the workshops page if you have anything in your interests area. Yeah, you can just register. And also the digital membership opportunities that we have to become a member and gain access to all these workshops. We had also, again, so many Iranian designers before in our platform, from IDA, from I forgot so many people that we had, Ariane, and great minds. So yeah, thank you so much again, and it was a nice session. Appreciate your
A
time.
pleasure, Amit. A pleasure. Thank you for having us.
Thank you so much, and take care,
You.
guys.
You too.
Thank you, Hamid, for inviting us, and it was a pleasure for me.
Thank you.
Bye-bye.
Take care. Bye.
Bye-bye.